how rocket launches may be delaying ozone recovery in the mid-1980s. Humanity faced a planetary crisis. The ozone layer, Earth's natural shield against harmful ultraviolet radiation, was thinning at an alarming rate. Through international cooperation, the Montreal Protocol phased out ozone-depleting substances, giving our atmosphere time to heal. But today, a new and unexpected threat has emerged. Asterisk, not from ground-based pollution, from space. Over the past decade, the number of orbital rocket launches has more than doubled. Each rocket that pierces the upper atmosphere leaves behind a trail of emissions, microscopic particles of soot, metal compounds, and reactive gases. These emissions don't dissipate like ground-level pollution. Instead, they remain trapped in the stratosphere and mesosphere for months, even years, where they interact with the very layer we fought so hard to protect. Published in NPJ Climate and Atmospheric Science, uses advanced climate chemistry models to simulate how rocket emissions could impact ozone recovery. Recent research led by Dr. Laura Ravel and colleagues, their projections show that by 2030, launch activity continues to grow as expected. We could see up to 0.3% global ozone reduction and 4% seasonal loss over Antarctica. That may sound small, but the ozone layer is still 2% below pre-industrial levels, and ISNT expected to fully recover until 2066. Even a small delay could set back decades of environmental progress. There are two primary culprits. 1. Chlorine-containing compounds from solid rocket fuels. 2. Black carbon soot emitted by nearly all propulsion systems. Chlorine initiates chain reactions that destroy ozone molecules. Soot warms the stratosphere, accelerating the very chemistry that depletes ozone. Interestingly, only cryogenic fuels, such as liquid oxygen and hydrogen, emit almost no ozone-depleting substances, but they're used in just 6% of launches today. Rocket launches are only half the story. Most satellites don't remain in orbit forever. At the end of their mission, they re-enter the atmosphere and burn up, producing aluminum oxides, metal vapors, and nitrogen oxides, all of which may also contribute to ozone depletion. These re-entry effects are not yet well understood and are not included in most current models. But as satellite constellations grow, especially in low Earth orbit, these emissions are expected to increase dramatically. To mitigate these risks, scientists are calling for proactive steps. Monitor rocket and re-entry emissions in the upper atmosphere. Regulate the use of chlorine-rich and soot-producing fuels. Promote cleaner propulsion systems, such as cryogenic technologies. Fund more comprehensive research on re-entry chemistry. If we act now, there's time to protect the gains made since the 1980s. The Montreal Protocol showed that global coordination can reverse atmospheric damage. We now face a similar challenge, at the intersection of environmental stewardship and the space age. The sky is not a limitless frontier. It is part of a delicate system that sustains all life on Earth. As we enter a new era of space activity, let us ensure that exploration does not come at the cost of Earth's atmosphere. Subscribe for more science-based content. Sources in the description, and stay curious. What's still unknown, and what we can do about it. Rocket launches are accelerating, and so are concerns about their environmental impact. New research suggests that emissions from rockets and satellite re-entry could delay ozone recovery by decades. In this video, we explore what the science says. Sources: greater than Ravel et al. NPJ Climate and Atmospheric Science.